Okay, we're going to take a look at question number 2. We're talking about fruit flies again, and we're talking about eye colors. So we're not going to throw out the legend here again. We're going to use the same legend that we've done. E1, dominant over E2, dominant over E3, dominant over E4. So if we use that legend again, we're going to go to the second step in our problem-solving steps, and that's underline the parent. So it's saying a fruit fly with apricot eye color, okay, is test cross. Now this type of question often throws students off because they're looking for two parents, and in this case they can't find it. It's saying they had some offspring, we'll get into that in a bit, but they're saying indicate the genotypes of both the parents. So when you don't know the genotype of both parents, you can't go on to step 3, which is the Punnett square. So we can't do that. So we go through our different series of problem solving steps, and what we're going to do is we're going to determine what we do know about the genotypes, and then we're going to go look for some babies, right? Some offspring. So if we take a look at the apricot, of course, that allele is E2, so it must have at least that. But nowhere's in the question does it tell you if it's heterozygous, homozygous, or it doesn't tell you what this other allele is. So what we're going to do is we're going to simulate that we don't know it by just putting a underline, just a line there. Okay? Now, test cross. This throws people off because people say, well, what's the other parent? A test cross, remember, is always done when you have an unknown parent. That's the apricot. We don't know that genotype. We know they have an E2, but we don't know the other allele. And it's always done, and this is the key here, with the most recessive trait, right? And if we take a look at eye color, the most recessive trait in eye color for fruit flies is E4, which is white. Now again, remember why we use that. It's because we don't need to get this guy analyzed by a geneticist or anything like that. If he has white eyes, he has to, we know the genotype, has to be E4, because the only way that you get a white recessive trait is if both those alleles are recessive E4s. Okay, that's why we use a test cross. So even though they didn't tell you a test cross with a white, you just have to know that when they say test cross is done with the most recessive trait. Okay, now they say indicate the genotypes of both parents, can't to the Punnett square. So what we're going to do is we're going to then, if you remember those steps, go look for offspring. And we're not just looking for any old offspring, we're looking for recessive offspring. So what we're looking for is if there's any white offspring. Unfortunately, in this particular question, there isn't. But we do see that there's some honey offspring. And if we know that honey, the only way to get honey offspring is if there is an E3 kicking around somewhere in one of these parents. One of the parents must have contributed this E3. Now, couldn't have been the test cross, couldn't have been the white, because they can only donate an E4 to any of the offspring. So we now know, by a matter of deduction, that this unknown apricot, the E2, now we know that they must have also been carrying an E3 allele for there to be any honey. And that's how we solve this question. Again, no Punnett square, we're just looking at babies. The only thing that threw us off here is that there weren't no recessive babies, but we seen that there were honey babies, meaning that there had to be an E3 that was contributed by that apricot. Okay, the other thing is make sure you know that a test cross is always done when one parent is unknown and the other parent is the most recessive trait, in this case being white. Any issues, give me an email and we can go over this. Okay, thanks guys.